everybody, it's Ms. Phoebus, and I'm back with another lesson, lesson 63, measures of center and spread. All right, so we're looking at choosing appropriate measures for center, either mean or median, and spread, either range. We're also going to look at something called interquartile range, and we're going to look at standard deviation. And we are also going to use appropriate statistics for center and spread to compare two or more sets of data. We're also going to describe the possible effects of the presence of outliers in a set of data that have on shape, center, spread in the context of the data sets. Here are our standards. We're going to use statistics appropriate to the shape and distribution of data, comparing center and spread. We're going to interpret differences in shape, center, and spread, and look at outliers. And we're going to turn to page 316. And when you get there, you're going to see this picture. And we've got a beautiful picture of some humps there, and we've got mean versus median. So when we have a set of data that is evenly distributed, the mean, the median, and the mode, the middle pieces of the data, and the mode is the one that happens the most, all happen right in the middle. But that doesn't necessarily mean that our data set always has to be that way. We can have what we call a skewed data set where things are pushed to the left or to the right, and we might have more lower value things that kind of happen. That's what the mode is, right? The number that happens the most. The median is the very middle number. If I organize them and put them in order from least to greatest and look to see what number is in the very middle, and then the mean is the average of the numbers, they don't necessarily have to be the same thing. So in the idea, and you've talked about mean and median before, and that mean is all about the values. So it takes all the numbers into account. And median is all about the center of the data set, and it ignores outliers. So if you are going to have to choose which one best fits, mean versus median, well, the question is, do you have a whole bunch of outliers or even an outlier? If so, then mean probably won't be the best one. And really, if you're going to choose, you should choose the median to be all about trying to find the center value of a data set. So if you have to choose between mean and median, choose median. Sometimes they happen to agree with each other, but not always. All right, so what we're going to do is we're going to calculate the mean and the median. And I know in years past you have looked at averaging numbers and looked at, ordering them and trying to figure out by hand which value is in the middle. But we, in Algebra 1, we're getting a little bit more advanced. We're going to use the graphing calculator to help us. So if you are not going to practice with the graphing calculator, you're only hurting yourself. So let's break out our graphing calculator. Here we go. And I'm going to teach you how to type in the values, where they go, and what to look for and look at in order to get the mean and the median. So what we're going to do is we're going to go back to stat, which is what we used for our scatter plots, and enter. But this is not bivariate data. This is what we call univariate data, and that means that there's only one variable, and this is the number of pets that are adopted each month from a rescue agency. So since there's only one variable, we're only going to put all of our numbers in L1. Now, the way that when you start thinking about test taking and things like that, they can make things look like a table. So be very, very cautious when you're thinking about, okay, is this univariate data or bivariate data? Do I have two variables or do I have one variable? So I could make this look like a table, and you might feel like you have to fill in L1 and L2. That's the only thing to watch out for. All right, so what we're going to do is we're going to type in each of these numbers. 18, and make sure you put them in correctly. 17, 15, and 20. And then what we're going to do is we're going to hit stat and write, which should feel very familiar, but we're going to stop there. We're not going to do the linear regression because you don't have enough stuff. We're going to stop right here. We're going to hit one variable statistics because we have one variable. right? And we want statistics on it. So we're going to hit enter, and then you hit enter a few more times, and here we go. So we got a whole list of stuff. The table keeps going down a little bit. So what you're interested in right now is the mean and the median. And so the mean, they don't actually spell it out. It's this very first symbol. It's an X with a bar on top of it. And if you are going to say that symbol, you read it X bar. X bar equals 16. So that means our mean is 16. All right. The median, you have to scroll down just a little bit, and they do spell this one out. There's not a special symbol. You see this MED. MED stands for median, and it happens to be the same as the mean. So both the mean and the median are 16. That means that our data is in that nice little bell curve that we were looking at on that first slide. Okay, so let's look at example 2. We have one variable. A statistician reviewed the number of points his high school team gave up on their home games this season. So we have one set of data, one variable, and so we're going to hit stat and enter, and we're going to fill that in. Now remember, you can go up and you can clear the whole entire list, but don't delete it. All right, 14 and 0 and 20 and 24 and 17 and 30. And then we're going to hit stat and write and 1 for one variable statistics. And hit enter a couple times. And then can you tell which one's the mean? 17.5 is the mean. Can you tell which one's the median? I got to scroll down. 18.5 is the median. So 17.5 is the number up at the top. That's X bar. So you could say X bar equals 17.5, and then the median is 18.5. Now, if they were going to say which one best models the data, we would probably say the 18.5 because there is an outlier. An outlier is a really, really big or really, really small number, and you see this 0 right here? That is a really, really small number in comparison to the other numbers. So there's an outlier, and that outlier pulls on the mean, drags it down, but doesn't quite so much affect the median. So calculate the mean and the median. So I want you to pause the video and see if you can figure out 3 and 4 using the graphing calculator. All right, you're back. And so here we go. We're going to pull up our calculator. We're going to hit stat and enter, and we are going to clear this out. And then this is probably the tedious part, right? Getting it all in the calculator. All right, I just finished, so you didn't have to watch me fill in my table. I just finished my data. I did make a couple mistakes, and I fixed them. Oh, look, I even made a couple more mistakes. Let me go back and fix this. 154, 150. It is very important that you type in the numbers and even double check yourself, because those numbers would have created an answer, but it wouldn't have been the right answer. So it's a good idea to go back and check yourself. All right, so we're going to hit stat, write 1, enter, enter, enter. And we've got a mean of 157.5 and a median of 172. And so that is, there's our calculator going through. There we go. That's it. Okay, so example 4, I'm not going to walk you through it because it's the same calculator stuff, but you should have already done it, right? Did you pause the video? And so if we pull this up, which one, this is the stuff that's in the calculator, which one's the mean? The mean is 12 because that's X bar. X bar is the mean, and then the median is 9.5. Okay. So that's how to do mean and median on the graphing calculator. Now, if we have to compare the mean and the median for 2 different groups, you're going to have to do them separately. There's not really, well, You could put class 1 into L1 and class 2 into L2, but be very careful because then you might end up feeling like you have to do two variable statistics, which is not what this is about. The other thing is that when you go to do the one variable statistics for class 2, you would have to change the L1 to an L2. All right, so let's look at class 1. So stat and enter, clear out everything, and we're going to put in the data. All right, I have all my data in. I paused the video so that I could put it on so you didn't have to watch me. But I did put L1 for class 1, L2 for class 2, just to show you what to do. But be very careful and do not run a linear regression for these. So if I hit stat, right, and 1, notice that I have L1 in there. It's going to just do the one variable statistics for L1. If I want to change that to L2, L2 is down here in the blue, so that means I have to hit second and then that button and it'll change it. But right now I just want L1. So my mean is 62 point, and you want to give some decimal places to let people know that it's not 62 exactly. So 62.368, or you could do 37. You could round to 0.4, 62.4, but I probably would at least give two decimal places. For my median, 64 exactly. So I think I did 37 here. Now let's compare class 2's mean. And so we're going to do stat, right, 1, but now I'm going to change this to L2. And you have to be kind of careful because in the future, I think it might stay L2 until you change it back to L1. So you might need to play around with that. So I'm going to hit enter, 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 and notice that I have different numbers, right? If the same numbers kept popping up, I might not have changed L1 to L2. So we've got a mean of 73.47. We've got a median of 74. And then if we are comparing the means and the medians, because class 1 has an after-school tutor, class 2 does not have a tutor, based on the data, is there any reason to believe that class 1 has an advantage with a tutor? Well, the mean is definitely higher in class 2 than in class 1. The median has a higher, class 2 has a higher median. So class 2 has a higher median and mean. Class 1's tutor does not appear to be an advantage, but more data is needed to show this. So you might have to look at this over time. This is just a snapshot at one point in time. Who knows how long they've had a tutor. It might have been for a day. It might have been for a week. If this is after 3 months, it might not be too great. Okay, but in case you have to later on compare two sets, do one at a time. Right? You can do L1 and L2, but you have to do them separately. And then come back together and kind of bring it back to the context of the situation. What's going on? What does the mean mean? What does the median mean? And you have to know something about grades, right? In this case, to be able to compare the two. So here is another one comparing the mean and the median. So what I want you to do is I want you to pause the video. I want you to work with a calculator. Remember, the more that you work with a calculator and you familiarize yourself with it and try to figure that out, the better it is for you in the long run. All right, you're back. I'm not going to put the calculator up because I've already got the answers. If you need help with the calculator or you get different answers, let me know. Okay, so the men's mean is 30.6 and the men's median is 30. The women's mean is 31.23 and the women's median is 32. We are talking about a 5-kilometer run. Okay, so just because they have a bigger number doesn't mean that they're better, right? Bigger number means that they're taking longer. So men are faster than the women. The mean shows that, and the median shows that. So the men's group has a faster mean and median. However, they also have a smaller group. Ooh, we didn't even look at that. Here we only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 sets of data. And then 1, 2, 3, 4, 5, 6, 7, 8, 31. The women's group has 31 sets of data. So the women's group is larger, but still has a pretty consistent mean and median. Those numbers are fairly close. I mean, the men's group is too, but with a smaller data set, you would expect those numbers to stay close. All right, now let's talk about measures of spread. We've got range and interquartile range. So range is about how far the data is spread out, and actually that's the whole entire meaning of the word spread. How far are the data points spread out? So the range looks at the entire data set, and that includes all the outliers. Remember those really, really small numbers or really, really big numbers? But the interquartile range, or IQR, which is why I like to write because it's a lot shorter, IQR helps you figure out how far the middle 50% of the data is spread out. And this helps us ignore outliers. So to calculate your range, you're going to take your maximum and subtract your minimum. Now, when you go through, you don't have to put your lists in order. You do not have to put your lists in order when you put them in the graphing calculator, but the calculator will get your maximum number and your minimum number. It will identify those. So instead of you having to hunt through a whole bunch of data, you can put it all in the calculator and it will give you the max and the min, and you just need to subtract them for the range. For the interquartile range, for the IQR, you need Q3 minus Q1, and those are the quartiles, and we'll talk about that in a second with this picture. But Q3 is given to you and Q1. So you can get all of this from the calculator. You just have to know what you're dealing with. And so, again, this is subtraction. You want the biggest number minus the smallest number, the range, the IQR. These should be positive values for the most part because they're distances. It's how far is it spread out. Now, what the Q's mean is we've split the data up into quartiles. Quartiles meaning quarters or fourths. So you're looking at Q1 happening here in between the first and second sets of data. And then in between the third and fourth, you have this Q3. And what you're doing is when you subtract those, you're trying to figure out how far apart the middle two pieces of data are, middle two chunks of data. All right, so for our measures of spread, we're going to calculate range and IQR. So more problems that we're dealing with the calculator. Look at the calculator again. And so we're going to go into stat and we're going to hit enter and we're going to clear out our tables. And then we're going to type in 6 and 8 and 10 and 4 and 5 and 9. And we're going to hit stat and go over to one variable statistics. Now look, L2 is still in there, so I want to go back because there's nothing in L2 right now. And I'm going to change it to L1. So you have to watch out for that. You could clear out the whole entire calculator and reset it. That is something else you can do, but pay attention to that if you are making a change. All right, so I'm not interested in mean, I'm interested in range. So range is 10 minus 4, max minus min. 10 minus 4 is 6. And then for my IQR, I'll do Q3, which is 9, minus Q1, which is 5. 9 minus 5 is 4. All right, let's look at example 2. We'll put it in the calculator. So again, this is just getting to know our calculator and what we can do and what we're looking for. And again, if you're choosing not to do it and you're choosing to use a Desmos calculator or some other online calculator that I've been seeing you guys watch doing and trying to block you and all that stuff, you need to be using this TI-84 because guess what? This is what you're going to be using, not the virtual one, but the actual one you're going to be using on the end of course test. And there's no Desmos. You get this. So please be practicing with the TI-84. If you don't know how to use it, ask. All right. That was my little rant for right now. We're going to hit stat. We're going to hit right. We're going to go 1. And we need to scroll down here. We want the max is 63 minus the min is 55. Now you might have been able to do that just by looking at it. That's fine. And even the IQR would not, it's a little bit harder to do by hand. But when you get into this, you may be having to look for multiple things. You might not just need the range and the IQR. You also might need the mean and the median and the this and the that. And so most of the time, yeah, you can do range maybe just by looking at it. But if you're already putting the data set in for other things, you know, why not use it? So this would be 63 minus 55, which is 8. And then our IQR would be the 61.5 minus the 56.5, which is 5. All right, so here is 3 and 4. I'm going to have you pause the video, practice with your graphing calculator, getting the numbers in, and then what's the range and the IQR for each one. All right, you're back. So example 3, we've got a whole bunch of numbers here, and our range is 9, because that's what 10 minus 1 is. Our IQR is 2.5. All right, for example 4, range is 35. The IQR is 19. How'd you do? All right, measures of spread. So back to mean and median. Bill Gates makes $50 million a year, and this was like a long time ago, so that might not be true. He might make more than that. He's in a room with 9 teachers, 4 of whom make $40,000, 3 make $45,000, and 2 make $55,000 a year. What is the mean salary of everyone in the room? What would be the mean salary if Bill Gates wasn't included? So let's pull up the calculator. So we're going to do stat. Gotta get it to where I can hit my button and enter, and then we're going to put in Bill Gates, 500 million, 500. There we go, 500 million. It's going to put it in scientific notation. All right, we've got 4 40,000s. We've got 3 45s and 2 55s. All right, we're going to do the mean with Bill. So the mean is, wow, 50,040,500. All right, and then we're going to look at the mean without Bill. So we're going to come in here. So stat and enter. Now let's say we want to get rid of Bill Gates. We're going to just hit on his number, not on the title, the heading, just on his number. We're going to delete him. Delete. And now we're going to hit stat right 1. And then now we're at $45,000. So Bill Gates is an outlier. Very much so. He really increased the mean of the room with his presence. Look at the difference there. This is a much larger number than this one. So outliers have a really large effect on the mean. Now, for just a second, it's not in here, but let's look at the median. So the median is, look here, where is it? Here it is. The mean is $45,000. Let's look at what happens when we go back and we put in our 50 million for our median. 500 million. Stat, right, 1. Okay, so 45, look at there, the median is the same. So the median is a good indicator of the center of the data instead of the mean, because the mean is easily swayed by outliers. All right, so an outlier is an observed point that is distant from other points, usually due to variability or an error within the experiment. All right, how to algebraically determine if a number is an outlier. So you can't just look at your numbers and go, huh, this feels like an outlier. Because there is like a boundary line. It's like, when does it cross over from being an outlier to not being an outlier? How can I prove that something's an outlier? So on the lower end, and you really need to write this down, it's an outlier if the value is smaller than the Q1 number minus 1.5 times whatever the IQR is. And the upper end outlier if it is bigger than Q3 plus 1.5 times the IQR value. Numbers in between Q1 and Q3 are outliers. So it's either smaller than this or bigger than this. And then if it's true, then it's an outlier. If it's not true, it's not an outlier. So what do you think in this list of salaries, what would be an outlier? Let's say for a moment we want to check and say maybe some of you think 25 is an outlier and maybe some of you think that 150 is an outlier. Some of you might even think that 60 is an outlier, okay? But we can't just go based off of feeling or what we think it looks like. We need some proof. So this is on the lower end, and so because it's on the lower end, we're going to do the Q1 minus 1.5 times the IQR. And if that is true, if 25 is less than that, then we are going to have a lower end outlier. If we look at 60 and 150, these are on the upper end. If we look at Q3 plus 1.5 times the IQR, and the number is bigger, so let's say 60 or 150 is larger than that value, then we will have an upper end outlier. So the question is, how do you figure out what these pieces are? And that's where the graphing calculator is very, very handy, right? Getting to know how to find and calculate these things. So let's get these numbers into the calculator. So we're going to hit stat, we're going to hit enter, and we're going to clear out this list. And we're going to put in 25, 34. All right, so I've got all my numbers in, and I'm going to hit stat and write in one variable statistics. All right, so I need to know what Q1 and Q3 are. So it looks like Q1's 35, Q3 is 47.5. So I'm going to write that down. Q1 is 35, Q3 is 47.5. Now I have enough stuff to be able to figure out if I have my outliers or not, because I need Q1 over here. So Q1 minus 1.5 times the IQR. So I know Q1 is 35 minus 1.5 times, now the IQR is going to be Q3 minus Q1. So that's going to be 47.5 minus 35, which is going to be 12.5. All right, now that number has to be larger than 25. If that's true, 25 is smaller than this value, then we have a lower end IQR, or we have a lower end outlier. Before I stick that in the calculator and compare, let's go ahead and let's do Q3 plus 1.5 times the IQR. And so Q3 is 47.5 plus 1.5 times my IQR is 12.5. And the question is that smaller than either 60 or 150? Okay, we've got two numbers we're comparing there, so that's why the two little numbers happen to be right there. All right, I'm going to grab my calculator. I'm not going to use the one on the board because it's just too large sometimes. All right, I'm doing 35 minus 1.5 times 12.5, and I get a value of 16.25. So is 16.25, is 25 less than 16.25? It is not. So there is no lower end outlier. Okay, now 34, not even an option, right? 25 is not going to be an outlier, 34 isn't. Outliers have to happen at the ends. Okay, let's look at, I'm going to type in my calculator, 47.5 plus 1.5 times 12.5. I get 66.25. Okay, so 66.25 is not less than 60, but 66.25 is less than 150. So 150 is an outlier. Now some of you may be like, hey, I knew that. I figured that out. But guess what? I proved it to be true. And so I have evidence, algebraic evidence, that 150 is an outlier. Not based on feeling, not based on, looks big enough. It's an algebraic outlier. So even 67 would be an outlier, right? Would you think that 67 is an outlier here? Maybe not. That 67 wouldn't be in our data set. We would have to add it, and it might change this a little bit, but you have to think about there are numbers that are going to be just slightly bigger, and what's that line that is going to be crossed? All right, here's problem number 2 in the outliers part. You are given a data set, -3, 5, 10, 12, 14, 16, 18, 24, 26, 49, and 60. Which of the following is true? So we have -3 being an outlier, 60 being an outlier, no outliers exist, multiple outliers exist, which can happen. You can have a lower end outlier and an upper end outlier. You can have 2 upper end outliers or 2 lower end outliers. Just kind of depends. So what we need to do is we need to figure out 2 things. We need to figure out what's Q1 minus 1.5 times the IQR, and what's Q3 plus 1.5 times the IQR. If we have numbers smaller than this, we have an outlier. If we have numbers bigger than this, we have an outlier. So we need to put our data set into the calculator, the graphing calculator. All right, so I have all my numbers in, and then I'm going to do stat right 1. All right, so my Q1 is 10. My Q3 is 26. That means that my IQR is 26 minus 10 is 16. So I want to figure out Q1 is 10 minus 1.5 times 16. And then Q3 is 26 plus 1.5 times 16. I'm going to get these numbers, and then we're going to look at our data set. So 10 minus 1.5 times 16 is -14. And then 26 plus 1.5 times 16 is 50. Okay, so do we have any numbers smaller than -14? Well, you don't. -3 is the smallest. Do we have any numbers larger than 50? Yes. So 60 is the only outlier. C is the correct answer. All right, so now what we're going to do is we are going to compare some things. So the data set shown below has an outlier. I don't know why 21 is underlined, but I'll go ahead and say that's not an outlier because there are other 21s. All right, so determine the outlier and then answer the question as to what happens to the median, mean, range, and IQR when the outlier is removed. So we've got to figure out what the outlier is. So for our upper end, we need Q3 plus 1.5 times the IQR. Now, how do I remember that? I've written it a lot over my lifetime. Q1 minus 1.5 times IQR. And we'll get those numbers. So Q3 is 29 plus 1.5 times the IQR is 8.5. And then 20.5 minus 1.5 times 8.5. And we're going to throw it in a calculator. 41.75. 20.5 minus 1.5 times 8.5 is 7.75, which we don't have anything in the single digits at all. So 48 is our outlier. Okay, so that is the work that goes behind figuring out if it's actually an outlier. And we don't have anything else in the 40s. Okay, so let's look at what we have when we look at the data set with the 48. We're going to also then look at the data set, these pieces, when we don't have the 48. So we already have the 48 in there. What I'm going to do is I'm going to just write down the pieces that I have. So I have the mean is, I'm going to do like these little slashes here because I'm going to take it out in a minute. So the mean is 25.24. The median is 23. The range is 48 minus 12, which is 36. The IQR is 8.5. Okay, so this is width. All right, so we're going to exclude the outlier. So then, look at this. I'll just move all these things. Look at that. I feel so clever. Okay, so then we're going to look at without. So we're going to hit stat. We're going to hit edit. And then we're going to go and clip that 48. We just delete it. Don't have to clear out the whole entire list. We're going to do stat, right 1 again. Okay, so without. All right, and then the median is 22.5. I can't see the mean right now. Hang on. The max is 23, or the range is 23. The IQR is 7. And the mean is 23.8. So it looks like everything decreased because it's an upper end outlier. So the median decreased, not by a whole lot, but still decreased. Sometimes that doesn't happen. Remember, with the Bill Gates problem, doesn't always have to decrease. The mean decreased, the range decreased, the IQR decreased as well. So just keep in mind that sometimes everything decreases. Sometimes things will increase. Like if I get rid of a lower end outlier, things might increase. There might be no effect. So if I get the same number, there might be no change. So that's how you're going to compare two sets of data by throwing out an outlier. Okay, so standard deviation. Another measure of spread is standard deviation, which best represents the average distance between each individual data point and the mean. So basically, they look at all the data and they say, okay, this number is this far away from the mean, and this number is this far away from the mean. They collect all of these distances and then they average them. This is the scary formula on how to create the standard deviation. I don't want you freaking out. Standard deviation, you see this little, it looks like a 9 did like a face plant. It's a little circle with a hat on it. That is your standard deviation symbol. It's a lowercase sigma, which is a Greek letter. And you don't have to worry about this. Don't cry. It'll be okay. But look right here. See this right? There's mean. We don't care about this. We don't care about this. You don't care about this. This right here is the standard deviation. So if they ever ask you what is the standard deviation, you're looking at this value right here. And so according to this one that we have here, we have a mean of 7. Our standard deviation is 2.16. So the average distance a data point is away from the mean is 2.16. N equals 6 means that there were 6 numbers. So if I have a small standard deviation, that means the values are really, really close together. A large standard deviation means that they're very, very spread out. So if you want consistency, you want things to happen very closely, all this, in the same way, like let's say we were making washers, right? And we were trying to make the washers be identical. But it's very hard to get everything to be super identical, super the same. So we might have things that are, measured in millimeters, and they might be off by like a fraction of a millimeter, but as long as I maintain that consistency and the size is about the same, I should have a small standard deviation because all those sizes, because I'm trying to make them be identical, all those sizes are going to be close together. If we walk into a room full of thousands and thousands of people and we take everybody's weight, we should not expect everybody to be consistent unless they're all, a certain type of people. People's weights vary widely, so we would expect to have a large standard deviation. So it's all about how far the data points are away from the mean, and then that goes into the spread of the data. So smaller standard deviations mean that numbers are closer together. Larger standard deviations mean that numbers are further apart from each other. All right, so let's look at standard deviation. Kyle can throw a baseball left-handed or right-handed. Here are the speeds in miles per hour, 16 throws from each hand. Compare the means and the standard deviations. All right, so I'm going to put the left hand in L1 and the right hand in L2. And I'm going to do that. It's going to be like magic. You should be doing that. Pause the video, get everything. Left hand L1, right hand L2. All right, so I'm back. I have my data in. My right hand is in L2. My left hand is in L1. And so what we're going to do is we're going to do our stat right 1 variable option, and we're going to write down the mean and the standard deviation and talk about those. So stat right 1. And I really want you to practice writing these symbols. So next to our left hand, that's we did L1 first. We're going to write X bar. X bar represents the mean. So I just want to make sure that you're clear that is what that value means. So 69.69. All right, and then we want our standard deviation. So we make a circle and then we kind of put a little hat on it. That's our standard deviation. I'll show you a different way to write it in just a second. And we've got 2.1999, so 2.2. All right, give me a decimal place or 2, but those keep rounding. All right, let's do the other one. So stat right 1, but then now I want to change this to L2. Okay, so then now for this other one, let me do a different color. I've got X equals 76.12513. And now you could also write ST, standard deviation, but I like you to know the symbol. I think the symbol is important because sometimes the symbol gets used and it's not spelled out. We got 5.27. Okay, so then let's talk and compare the two. So we have and we are throwing a baseball left-handed. So the average speed for the left-handed ball is about 69 miles an hour, almost 70 miles an hour. And then for the right hand is 76.13 miles an hour. So we're looking at a faster right-handed throw than a left-handed throw. However, we are more consistent. We are throwing numbers that are around the mean more than with our left hand than with our right hand. So our left hand is more consistent than our right hand. So we throw faster with our right hand, or Kyle throws faster with his right hand, but more consistent with his left hand. And so that's what it means. So a smaller number means more consistency. You're closer to that mean, and so you're not like wildly throwing things, super fast or super slow in this case. All right, so here's another one, the scores that Jenny received from the judges, and we want to find and interpret the standard deviation. So again, we need a calculator. We're going to hit Stat. We're going to Edit. And we want to get L2 out of there completely. And then we'll fill in L1. So we've got 6, 6, 5, 5, 5, and 6, 5, and then these numbers feel very consistent, right? So we should get a relatively small standard deviation, I suppose. So let's see. Oops, go to. There's a problem. I didn't use my L2. Let's clear that out. Stat, right, 1. I've got to remember to change this to L1 because nothing is on L2. And then standard deviation. Okay, so look, 0.33. These numbers are really, really close, right? So 6 and 5.5 happens a whole bunch of 5, not a whole lot of deviation, right? So we have a very, very small number that would mean that the values are consistent. So there's not any judges that are being very, very favorable to her and she doesn't deserve it, and then nobody's like, you completely suck and she's actually good. They're all in about the same area. All right, so we're also going to look at the 5-number summary today. The 5-number summary is a summary that gives you a rough idea of what your data set looks like. We will need this next week when we're building our graphic displays of data, especially our box and whisker plot. So the 5-number summary is going to come from that second part. So let's fill in this first part. So over here on this piece, the pieces that you need are the mean, which we've already looked at, X bar, standard deviation, which looks like the number of values, and that might be something that's helpful. Like so I use this piece. So like if the problem says sometimes it's like 30 people were asked such and such, and I go back and it's like I have 22. It's like, whoa, I missed some things. So that is something that you can look at. But over here, the 5-number summary is your min, your Q mix. I can't spell. Your min, Q1, median, Q3, and max. So they're all right here on that second or the lower part of the screen. So if they want the 5-number summary, that is what they're talking about. Min, Q1, median, Q3, and max. So here we have a table of shoe sizes, and we need to give pretty much everything that they're asking for. But sometimes they actually just say, give me the 5-number summary, and you have to know what that means. So you need to make sure you are labeling these, especially if when you're writing things down on notebook paper for me to grade for homework, you need to label. So I'm not guessing what's what. You need to be clear. So mean, standard deviation are 2 different numbers, and min and Q1, median, Q3, and max. They all need to have a label if you are not writing them on something that is already kind of like labeled for you. So we've already kind of looked at these pieces individually, and so what we're going to do is we're going to just pull them all together. That's it. So we're going to put this into the calculator. Now, this is kind of where I was talking at the beginning. You have to be careful. It looks like a table, and we could even just stack all of these down here and make it look like an XY table. But this is one variable, shoe size. So all of these, even though it's a table and it's got columns and things like that, we have to make sure that each data value goes into L1. And so just watch out for that. It would be something that would be kind of a tricky-ish problem, trying to kind of get you on the end of course. So just watch out. All right, got them all in. We're going to hit stats, right, 1. Got my L1 in there, looking good. Okay, so for mean and standard deviation, I'm going to pull those before I scroll down. So my mean of this data set is 11.5. My standard deviation is 1.75. Those are pretty close together, especially looking at the numbers. And then min is 9. Max is 15, Q1 is 10, Q3 is 13, and the median is 11.5. And that's pretty much all you're doing with the 5-number summary. All right, so here's what you're going to do. Example 4 is going to be your exit ticket for this lesson. So I want to make sure that you can pull all of those things, label them for me, and be able to show me what you've got from the calculator. So I want a picture of your calculator. Let's see, a picture of your calculator, some sort of screen here, or where you scroll down and you show me your 5-number summary, something like that. Actually, probably all the way down. Do a screenshot of this. I don't see the mean, but I do see the standard deviation and then the 5-number summary. And then you can do 2 screenshots, or you could do a write them on paper. I'll give you some options. So 2 screenshots or write them on paper for me. And really, I'm just trying to make sure that you're putting it in the calculator, so then that way, right away, you know, are you doing it right or are you not doing it right? So that's my thoughts behind the exit ticket. Just because we're not in class and I can't walk around and be like, hey, that's not quite right. We need to fix it. All right. I will see you guys soon, some of you. I'll see you guys in the next video. Bye.